All right, so I mentioned this is not really how police procedures work. That's because it's not. This example is not really designed to talk about police procedures. It's used that as a colorful example. This is really about something much more fun, which is nuclear annihilation. So this game was developed during the Cold War when you had two major alliances in the world. You had NATO, which are all the blue over here, and you had the Warsaw Pact, which is sort of cut off, but is the Soviet Union and its many allies, or parts of the Soviet Union. So they both had a lot of nukes, a lot of nuclear weapons going around, more than there are today, a lot of nuclear weapons. And this is bad for a couple reasons. One, super expensive to keep a bunch of nukes. Two, you might, blow up the world. That'd be bad. You might even do it by accident, right? It could be a computer glitch, could be somebody just making a mistake, and then suddenly the whole world explodes, and that would be bad. So both sides of this expressed an interest in being able to disarm some of their nuclear weapons, just bring down the number of nukes. And they had a lot of diplomatic meetings and said, yeah, we both like to reduce the number of nuclear weapons that we have. And thus the game, right? So here's the problem. You go to the diplomatic meeting, you say, hey, I think it'd be great if we both had fewer nukes. And they say, yeah, I agree. I think it would also be great if we both had fewer nukes. And then you go back home and you call up, your nuclear deactivating person, and you say, I think I'm thinking about deactivating some nukes. Wait a minute, should I actually do this? Right? Or are you going to follow through on what you said, where you're going to deactivate some nukes, or are you going to go back on your word and keep all the nukes that you have? And you have to think about not just whether you're going to do it, but also what you think the other side is going to do. Right? So here's our game. We have NATO, we have Warsaw Pact. Those are our players in this game. And we have our options. You can either disarm your nuclear weapons, or at least some of them, or you could not do any of that and just stick with what you have. Same thing with the other side. Warsaw Pact could either disarm their nuclear weapons or not disarm. We have our actions, we have our players. What are the payoffs here? So if everybody disarms the nuclear weapons, there's no nuclear war, which is great. If nobody disarms the nuclear weapons, then if there is a war, then it's possible that basically everything's going to blow up. Everybody's going to be destroyed. Certainly both sides of the conflict are going to be destroyed. Okay, so clearly we'd rather be here than here. But you go home, you get your person on the phone, you think, wait a minute, what if I disarm my nuclear weapons and the other person doesn't? Where does that leave us? Well, if you're NATO and you think, well, what if we do disarm, but the Warsaw Pact was lying and they don't disarm? Well, in that case, they have nukes and we don't. They're going to blow us up, and they can make us do whatever they want. We're going to lose the Cold War. Same thing the other direction. What if we think that they are going to disarm? We think they're going to stick to their word. And we think, oh, okay, well, I guess they stuck to our word. We better disarm too. Wait a minute. If we have nukes and they don't, we win the Cold War. So if they disarm and you don't, then you win. So while you'd clearly rather be here than here, you really don't want to be here as NATO, and you really don't want to be here as the Warsaw Pact. And in each case, whatever you think the other side is going to do, it's in your interest to keep your nukes, right? If you think that if you're NATO and you think the Warsaw Pact is going to disarm, well then yeah, this is great. You'd rather be here, right? You'd rather win the Cold War than be assured that there's not going to be ever a nuclear war. What if you think they're not going to disarm? Do you think they're lying? Well, you'd much rather keep your nukes, because if you get rid of them, you lose. And this is bad, but you might also just might be mutually assured destruction. They keep it from happening. In any case, you could get blown up and they don't. So you'd rather be here than here. And so from this, we can predict what the outcome of this game is likely to be, that neither side is going to want to actually get rid of the nuclear weapons, no matter what they say at the diplomatic table. But in fact, this is what happened, right? Nuclear disarmament did not really happen to any degree until after the Cold War was over. We kept a lot of nukes. We still have a lot of nukes. They've slowly been sort of phased out a little bit, but we still have lots of them. And this incentive is sort of what's going on, right? Why it is so hard to get rid of the nukes or make that case. So this is a concept called Nash Equilibrium. This is a solution concept. How are we coming up with the solution of this game? Right? We've basically said, how do we figure out what's going to happen in the game? We look for those best responses, and we figure out what best responses are. And we're going to be looking for places where both sides are playing best responses. So the general idea here is Nash Equilibrium. Nash Equilibrium is when no player can improve their own payout by changing their strategy. This goes back to our other ideas about equilibrium, like in the market. A market equilibrium happens when nobody can make themselves better off by buying more or less stuff or making more or less stuff. Here, nobody can make themselves better off by changing their strategy. So in other words, in a Nash equilibrium, the definition of a Nash equilibrium is it's the outcome where everybody is playing a best response to each other at the same time. If you have ever seen the movie about John Nash's life, they get this concept entirely backwards. So don't rely on Hollywood for that one. But you know, won an Oscar. So let's think about that. Let's go back to our idea of the prisoner's dilemma, right? Here's where we ended up. This is a Nash equilibrium because both players are playing a best response to what the other person is doing at the same time. If I think you're going to confess, what's my best response? To confess. If you think I'm going to confess, what's your best response? Also to confess. So confessing is the best response to confessing. I'm playing best response to what you're doing. You're playing a best response to what I'm doing. We're both playing best responses at the same time, which gives us a Nash equilibrium. So let's take it back to the game that we played here. Right? So you probably have noticed by this point that this is basically the prisoner's dilemma. Right? It's the exact same thing. I just put dollar amounts on the board instead of points or whatever. Right? So let's think about our best responses and the other person's best responses. So the way we're going to do this is we're going to go hypothetically, strategy by strategy, or option by option, and figure out in each case, if some person played this, what would the other person's best response be? And you always want to keep in mind who's controlling the rows and who's controlling the columns, because you don't want to get those two mixed up or you get the wrong answer. So let's start with figuring out your best responses. So you control the rows. You control which row of the table you end up in, right? They control the columns. So we're going to basically pick a column for them and figure out which row we would want to be in as our best response. So if we think that they're going to cooperate, what are our options? We can either, so now we know we're in this column, we can pick between the rows. We can either cooperate as well and get 15, or sorry, get 10, or we can defect and get 15. 15 is better than 10, so we'd rather, if we think they're going to be in this column, we'd rather be in this row. So this is our best response. How about if we think that they are going to defect? Right? Hypothetically, if they defect, we know that we're in this column, we can choose between the rows. Because we control the rows, we can either cooperate and get 0, or we can defect and get 5. 5 is better than 0, so we're going to circle that as our best response. We now have our best responses in this game. Now we switch it up. We think about what their best responses are. Right? You can't figure out a strategic game if you don't think about how everybody in it is going to act. So if they think we're going to cooperate, they know we're in this row, which column do they want to be in? We're going to compare their numbers, right? They can either cooperate and get 10, they can defect and get 15. 15 is better than 10. So we're going to circle their best response here. If they think we're going to defect, they know we're in this row, they can choose either to cooperate this column or this column. If they cooperate, they get 0. If they defect, they get 5. 5 is better than 0. So their best response is that. So we end up with this cell down here, where both players are playing the best response to each other at the same time. And that is our Nash equilibrium. You can also notice, by the way, we didn't start out over here. Right? The first time we played the game, it was pretty evenly split between cooperate and defect. We had people all over the board. But as we played more and more, we got more and more defections, which sort of pushed a lot more of the outcome down here. So this is exactly how Nash equilibrium works, right? This is not necessarily a claim about the first time everybody plays a game, they're going to play exactly the Nash equilibrium. It's that the incentives of the game push you towards the Nash equilibrium. As you play it and you get feedback on what your payouts are, you realize, hey, wait a minute, this Nash equilibrium thing is, or whatever the strategy is that leads to this Nash equilibrium thing is my best option. You figure out how to play the game. As you do, people tend to play the Nash equilibrium more and more. If we kept playing, we probably would have ended up with pretty much everybody defecting every time. And that's exactly what we got in our game.